So, right. And the app just froze. Did it freeze completely? Let's look at our debugging session. So, looks like there's a lot of thresholds being passed. You know what it is? Yes. What is it? Well, since we're using this flag, the analyzing flag, we're using it in a way that we're assuming that we decrement it once in this analysis pass, once we analyze it, or once we're finished looking at the individual samples. Yeah. So right here, once we're done with it, we have to make sure to decrement it. Yes. Yeah, that's pretty hacky, but whatever. Let's try running this again. So it's also, another problem is, like I said, the mic and speaker are both right here, and I'm forcing the output through the speaker. The default will go out through the headphones, which are much softer. Okay, so I gotta silence this guy. But you can see, maybe you can't see because of all this stuff. When there's no sound, you don't see a lot of past. When I don't speak, there's also not a lot of past. When I speak, you can see, shit, I'm sorry. Yes, you can't see my computer unless I put it on the screen for you. So, right now the debug log doesn't have much on it because it's not crossing our threshold. But when I go close to the mic, you can see that when I go close to the mic and speak, the word past pops up on the screen. Yeah. And that's pretty good. That means this thing's pretty much working. We do notice that we cannot use this threshold while the speaker's active though, because I'll add some noisemakers. So if I tap this a bunch of times, the sound feeds back into the input and you'll get a pass. That's not the best word. Cross is a much better word. Yeah. But we got a working threshold detector. Onset detector, sorry. And that's good. With that alone, you can do a lot of fun stuff. Yeah, for now I think I'm going to add new, so instead of tapping the screen, I'm going to add these voicing things every time there's an onset. I don't know what to call it, a voice being detected. And okay, so how are we going to do that? We got this code here now. It's working. I didn't say delete messages, but that's right. We took that printf away. Okay. Let me have a drink of water. Alright. So right here is where the magic's going to happen. What we want to do is insert one of those bouncy balls right here. But we don't want to do that right in this loop without a condition, because if you're speaking into the mic, it'll pass the threshold each time. You want to record when the threshold is passed and also when it is released. And you generally, you know what, it'd be good if there was a Microsoft Paint kind of program. I did install a bunch of them, but I used oh, there's empty paint. Oh, they are in here, great. I forget which one I like. Empty paint sounds about right though. Yeah, so this will be useful for me too. No, it's not empty paint. It is my paint. I believe it's my paint. Please be the one. Yeah, this is such a fancy app. Have you ever seen this app? I hope real Linux users are not offended by me calling programs apps. I'm obviously a Mac user. I've been a Mac user much longer than a Linux user. I've been a Mac user since, God, I use System 6, but I really started getting into programming in System 7.0. That was in maybe 94, 95. Anyway, so when I'm speaking, this is power and this is time. Right? So when it's silent, you're like this. When you say something, you'll suddenly get a spike up here. And with speech, it's very tricky because the plosives may be very large, and then you do have, sometimes you'll have silence between sentences or words, but generally when someone's speaking, it stays up. It doesn't drop too low. There's not a lot of pauses except for between, and when there's a comma, that's clear separation of phrase. But you do get stuff like this. Okay, so if it was like this, there's no issue. But what really ends up happening is it ends up being like this, right? There can be some things like this, and if you're, it's not good. It can be like this. It can go up in steps, and this is when you're talking, and then it comes down. It probably comes down a lot more abrupt than that, but forgive me. And say your threshold's right here, and this is one phrase. This is someone going la 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 or something. Can't believe I just made that totally incredible sound. If this is your threshold and your release, and you make a note for each one of those onset offsets, you will make you will detect 1, 2, 3, 4, 5 points. And that's no good. This should be one. This is one word or one sound that we want to catch as one group. So what that means is we need an onset that's kind of high, and we need an offset. We need a silent value. That's much lower, like that. And the actual room silence is maybe around here. This is what we expect. This is a very messy drawing, but I think you get what I'm saying. So this is onset, on, and this here is offset, off. And one other tricky thing is that you have to save the stuff before the onset, because this is probably part of the word. There's a chance, especially with some kind of instruments that aren't percussive, like a violin, the sound slowly ramps up. Instead, with a guitar, it's just bam, and starts loud and gets softer. It's great for this kind of onset detection. For violins, that's not going to work because you're going to miss the initial energy of the note. So you got to back up a little bit, and that's not hard to do if you have. And you will have to have an estimate for what the offset, the note release, I guess is a better word. But anyway, that's the theory. Now we just have to implement something like that. And that being said, pretty much do anything that uses the onset and offset, and you'll be good. So, what should the offset be? I know that this right here is the... Oh, that's right. I was going to look at the silent values using the squared, non-squared. But I don't know if that will have so much an effect. Being a human, I like small numbers because I can look at them and figure them out. To the computer, it doesn't really matter. Yeah, so this is 7 digits. What did our value have? 1, 2, 3, 4. This is 8 digits. So this is already on the larger end of the silence. But if you notice, the average sum squared is around 2,000 to 5,000. So the actual value is like, what's the square root of 2,000? God, I hate doing stuff like that. Maybe it's like 50, 44. I'll say 44. Is that even right? 44 times 44 is... 40 times 40 is 1,600. That's pretty close. Okay, so it's a value like that. Yeah, it's easier to think about, but you know what? So anyway, this value is on the upper end. So we'll call this release threshold squared, and we'll make one more, and we'll call this the no, we don't take one more. You know what? The way that you get the stuff leading up to here, we call this the attack portion, right? The attack. This is a very messy one, so you'll have to bear with me, but this is the attack. Attack. It's generally rising, so you take a low value and you just watch that it's monotonically increasing until it passes your threshold. And we're not talking individual samples, we're talking buffer sizes of from 256 to 1024 samples, so that happens maybe 40 times. Yeah, 160 to 40 times a second. So we do have this flexibility. Okay. So we do need this, we need to track the state, and we'll need a variable for that in the input manager. We're going to call that double, no. We will call that what do we want to call it? State. We'll call that state. Attack state.